Well, have you ever driven along the road in the dark, especially when it's misty? It's hard to see anything that you're driving past. Even if a pedestrian were dressed in all white, the amount of light being reflected back to you is still very minimal. Poor ambient lighting situations present an engineering problem. How can one make objects really bright when driving past them? The problem with the mirrors is that the reflected light would focus back into the driver's eyes, rendering them completely blind. So the challenge here is to design something that catches light from many different angles and is visible to drivers, and of course doesn't blind them. The basic principle of a retroreflector is that it reflects light back to the observer by combining the angle of reflection in two mirrors. The total angle of reflection is always 180 degrees, meaning the light will reflect parallel to the driver regardless of the angle. A cat's eyes work similarly to retroreflect light for improved visibility while night hunting. If you were to examine a bicycle reflector, it reveals a surface covered with holes in the shape of 90-degree corner angles. Retroreflectors can be used in roads, also known as cat's eyes, to separate drivers from oncoming traffic in poor lighting conditions, or as an illuminator of pedestrians and cyclists. Retroreflectors are more than just illuminators and have more practical uses for physics. Because retroreflectors work for all incident angles, we now know that Earth and Moon distances increase by 3 to 4 centimeters per year.